formulas, but I'm going to call it something funny. Everybody write on here. You're going to write molecular and empirical, but instead of writing formulas, I am going to write formulas. Okay? Now, we talked about mass percent. And in mass percent, what happened was they gave you a formula and they asked you for the percents in each compound. Okay? And the idea was that we would figure out what the percents were, but it was by mass. So for example, if you had something like NaCl, does that mean that it's 50% Na and 50% Cl? No. Why not? They weigh different amounts. So Na and Cl weigh different amounts, so that by percent, their percent composition or mass percent is what we call that. They actually, it's not 50-50, okay? Something like H2O we were talking about as well, something like water, same thing. It's not 2 parts hydrogen and 1 part oxygen, even though by the moles it is. When you go to actually figure out the mass, it's 2 H's and 1 O. But if you do this by mass, the mass of hydrogen is only how many per mole? 1 gram. And the mass of oxygen is what? 16. So by mass, this actually ends up being way more. And what we calculated was, we said that hydrogen was only actually 11.1% and oxygen was 88.9%. So it's really only by mass about 1/10 hydrogen, even though there are 2 of them. And it's basically about 90% oxygen, even though there's only 1 of them, okay? So I want you to keep that in mind, that when we write the formula, though, I'm going to call it a formula, because the formulas are based on how many what that you have? Moles. How many moles, okay? So, as long as you know the moles, you can write a formula or a formula. And I wanted to make sure that you remember that. So what we're going to talk about is molecular and empirical formulas. Now, we've already heard about molecular formulas. We've been talking about molecular formulas since we were naming. Remember, molecular compounds are compounds that are typically made of the nonmetals, and they share electrons when they bond. We called those molecular formulas. Now, all of those will be molecular formulas, but it might also be an empirical formula. All an empirical formula is, it gives you the lowest whole number ratio of the atoms of elements in a compound. That's all it does, is it's the lowest whole number ratio. Okay? So, for example, if you had something like ethane, remember there was Matt eats peanut butter? Yeah. So ethane would be how many carbons? C2, and then times 2 plus 2 would give you H6. Awesome, so C2H6. Now that would be called the molecular formula. Is that reduced? Is C2H6 reduced? No. What can you do to reduce it? You can divide both of them by what number? 2. And when you do that, what do you get? CH3. This would be called the molecular formula, and this would be called the empirical formula. Okay? So the empirical formula is simply the reduced ratio of the elements in a compound. That's all it is. All right? So some molecular compounds, remember we said we don't reduce them. You could have dinitrogen tetrahydride, and that's a 2 and a 4. Okay? And then, then you could figure out what the empirical formula is just by reducing it. So what we're going to first do is, and it says you have to convert to moles to calculate it. And so that's why I call it a formula. That's the only reason why I'm going to call it a formula. So let's calculate empirical formulas first. So the empirical formula, again, is the lowest whole number ratio, I'm going to say B/W between elements in I'm just going to say CMPD in a compound to abbreviate compound. So it's the lowest whole number ratio between elements in a compound. Just repeat that. So what's the empirical formula, everybody? Lowest whole number ratio between elements in a compound. That's all it is. It's the lowest whole number ratio between them. What are we calling it? To find the empirical what? Formula. Good. Formula. When you're given percent composition, you're going to perform 3 steps, okay? The first one is the easiest of all the steps. I'm going to use a triangle for change. Okay? So I'm going to use a triangle for change. The first step is, if you are given percents, you are simply going to change your percent symbol to a G, meaning grams. Okay? You literally are going to take your percent symbol, you're going to cross it off, and you're going to make it a G for grams. And the reason why we're doing this is, let's say that I said that something was 75% X and 25% Y. If it were out of 100 grams, then 75% would be what? 75 grams. And 25% would be what? 25 grams. Since percents all add up to 100, then it makes it really easy to just say, let's just change our percent to grams. And in parentheses, I'm going to say it's basically out of 100 grams instead of out of 100%. Okay? So we're going to make it out of 100 grams instead of saying 100%. Second step. Once we're in grams, we don't want grams. Everybody, they're called for what? For molas. So guess what we want to change grams to? Moles. We're going to change grams to moles. How do you change grams to moles? L chart. We're going to do a bridge. Okay? You won't need an L chart necessarily because they're single elements. So you won't have to add anything up. It's just single elements. So what you're going to do is you're going to take your grams of X, of whatever your element is, and you're going to throw in a bridge, and you're going to cross your grams opposite, and you're going to go to moles. Don't forget, 1 always goes with a mole. And whatever your number is, this you're getting from the periodic table. Okay? That number there you're getting from the periodic table, and so you're just going to switch grams to moles. Once you have your moles, the last step is kind of two-part, okay? You're going to write your formula. You're going to write your formula, and I want you to write, do not round yet. And then, once you do this part, once you write your formula, you are going to divide by the lowest number of moles, then round. Okay? And I'll show you what I mean. Right? So you're going to divide, you're going to write your formula, don't round yet. You're going to divide by the lowest and then round. So I'll show you what this means. We're going to come back to this. It just says if the result of dividing by moles is far from an integer, then multiply through by a common factor that converts to integers. And I'll explain that in a minute. We'll do some problems together, and then we'll come back and we'll explain this because we need whole numbers. All right, let's try it. The best way to learn this is just to practice it, okay? So if you feel like after we do letter A, you know what you're doing, the only thing I'm going to tell you is you need a little bit of room. Some of you may want to pull out a blank sheet of paper if there isn't enough room in your notes. Otherwise, just write small, okay? Smaller than you're used to. So what I'm going to do, first step, step number 1 is I need to convert my percent, change my percent sign to grams. So it's as simple as 94.1 grams of oxygen instead of percent. And then right here, I'm going to have to do a bridge, so just be careful with this. I'm going to do 5.9 grams of hydrogen. So all I did is I literally just changed this percent to a G, and I changed this percent to a G. That's the first step. Pretty easy? Yes. Okay. Second step. Next step is we need to change our grams to moles. So now that we're in grams, we need to switch it to moles. So I'm going to do a bridge, and I'm going to put my grams down on the bottom, and moles go on top. What number goes with the mole? 1. And everybody probably knows oxygen's molar mass is 16.0. Now, you're probably looking at that and you're thinking, but oxygen's diatomic. Why isn't it O2? Why isn't it O2 in this case? It's in another compound. It's not alone. If it's alone in nature, its oxygen is O2. This is not alone. This is oxygen with hydrogen. As long as it's with something else, it's just going to be the single atom. Okay? So this is just O. Now let's do this for H. So I've got H. Hydrogen's molar mass is 1.0. We're going to write 1.01 grams for every mole, just because that's what WebAssign uses. So we'll use 1.01. So I'm going to do 94.1 divided by 16. And do your sig figs. So I said don't round yet. Okay, we don't want to round yet. So this is 5.88 moles of oxygen. And now we're going to do 5.9 divided by 1.01. And this is giving me 5.8 because of my sig figs on this. Or I'm just going to write 5.84 anyway. You're going to see it doesn't really make a difference anyway because our sig figs, we're trying to get a formula. So the more you go out, it's not even going to matter. The better your answer will be. Okay, so that's our second step. Our second step was to convert from grams to moles. The third step is, it said write your formula first. So step number 3 is write your formula, which is going to be O 5.88 and H 5.84. Okay, so again, don't round yet. Okay. It says, let's come back to it for 1 second here. What it says is, don't round yet. Then it says, divide by the lowest moles. If I had 12, 16, and 4, and I divided by the lowest, what happens? The lowest number is what? 1. If you divide by the lowest one, your lowest number will always be 1. Okay? So in this case, which one's the lowest of these? 4. 4 and 4. So I would get a 3, I would get a 4, and I would get a 1. Anytime that you divide by the lowest, your lowest number will be a 1. And this really helps when we're doing these because the formulas have to be in whole numbers. So we know as long as our lowest number is 1, it's going to really guide us in finding the how many we have of all of the other elements. So let's come back here. Which one's lower, 5.88 or 5.84? 5.84. So I'm going to divide both of these by 5.84. 5.88 divided by 5.84 gives me 1.01, which is basically what? 1. And 5.84 divided by 5.84 is what? 1. The formula of this is OH. And we're done. Now, I'm actually doing this as an easier way of writing that I'm dividing by both. What some of you may want to do, because sometimes you'll have 3 things, or like in this case we have 4. What some of you may want to do is actually write O 5.88, H 5.84, divide by 5.84, divide by 5.84, and then again, that gives you O 1.01, we're going to round now, and H1, which is just OH. So I'm doing it just by saying that I'm dividing all these just to simplify it. Correct math, though, symbolizing this with correct math would be this way. All right? So let's try this next one. Again, you have to write really small, okay, if you're writing on your paper. Otherwise, you might want a different piece of paper. So I'm going to do CH here, and then I'm going to do NO here, and then we'll figure out our formula for it. All right. So step number 1. Step number 1 is change your percent to what? Grams. So all we're going to do is literally just change the symbol to a G. So we've got 27.59 G of carbon. Then we've got 1.15 G of hydrogen. And we're going to come over here. We've got 16.09 grams of nitrogen and 55.17 grams of oxygen. Any questions on the first step? Because it's important that you know that what we did is really easy, right? Okay, second step. Step number 2 is change your grams to what? Moles. Awesome. So you could just start dividing by the molar mass. So you could just say divided by 12 grams per mole, divided by 1.01, divided by 14.0, and just write your answer to make it quicker. I'm going to do this out just so that people don't get confused that need to see this out. Okay? So carbon's 12 grams for every mole. Hydrogen is 1.01 grams for every mole. Nitrogen is 14.0 grams for every mole. And we all know oxygen is what? 16 grams for every mole. So let's divide these out. We've got 27.59 divided by 12.0. And that gives me 2.299, which would be what? 2.30 moles of carbon. Then I've got 1.15 divided by 1.01. And that gives me 1.14 moles of hydrogen. Okay, next one I've got 16.09 divided by 14. and that's 1.15 moles of nitrogen, and 55.17 divided by 16, and that's 3.45 moles of oxygen. Let's stop there. This is step number 2. Okay, all we did was we converted grams to moles over and over and over again. Even though it's long, is it difficult? No. So nothing's hard about it, it's just that it's long, because you have to do it for each one. Okay? So now we've got our moles. Once you have your moles, you can write your what? What do we call that thing? Formola. Everybody say it. Formola. It sounds Italian. Yeah. Okay. So now we're going to write our formula. Okay? So now we're going to write it. You're going to write C 2.30. Don't round yet, okay? Don't do any rounding yet. We're going to write it, bless you, in the same order that's on here. H 1.14, N 1.15, and O 3.45. Again, you can do it this way, okay? But for the sake of time and speed, I think it's a lot easier if I just do one line and say that I'm dividing each one by what number? What's the lowest one? 1.14. So again, I'm going to divide every single one of these by 1.14. When I do that, what is 2.30 divided by 1.14? 2.02, which is basically what? 2. So that means that it's C2. Okay, what's 1.14 divided by 1.14? 1. H1. All right, and then we have the N, 1.15 divided by 1.14, which is just basically 1. And then O, 3.45 divided by 1.14, I get 3.03, which is basically what? 3. This is called your empirical formula. Why is it called the empirical formula? Because it's simplified, it's reduced. The reduced one is the empirical formula. Now, it might be the molecular formula. For example, what is water's formula? H2O. Is that empirical? Why is that empirical? You can't reduce it any further. It happens to be a molecular formula also, okay? So water is a molecular formula, H2O, and H2O is also the empirical, okay? Let's try one more. So if you think you know how to do this, go ahead and try this one out. There is one final thing on this one that's different, okay? You're going to get to the end, and I'll show you what happens with this one. So I've got step number 1 again is just change your percent. By the way, if they give you grams, you skip step 1, okay? So if they already give you grams, you can skip that and you're going straight to step 2. If they give you moles, you can skip step 1 and 2 and go straight to 3, okay? So here I've got 53.73 grams of Fe and then 46.27 grams of sulfur. Right, so iron is 55.8 grams for every 1 mole, and sulfur is 32.1 grams for every 1 mole. So I've got 53.73 divided by 55.8, and that gives me 0.9629, so what would that be? 0.963? Good, moles of my Fe. Then I've got 46.27 divided by 32.1, and that gives me 1.44 moles of S. All right, so that was step 1, and then I just did step 2 where I converted to moles. What's step 3, everybody? Write the formula. Write our formula. So Fe, again, don't round yet, 0.963, S 1.44. You always want to divide by the lowest, which in this case is 0.963. And when you do this, you're going to see that there's a problem. Okay? If you divide this, what you get is, well, that's easy. 0.963 divided by 0.963 is just 1. But when you divide 1.44 by 0.963, you get 1.495. What is that really close to? 1.5. That is not close to 2 or 1. You do not over-round that. That is 1.5, okay? But we need whole numbers. And so the question is, if there's one of these for every 1.5 of these, How can we make it the lowest whole number ratio? What's the easiest way to make a half into a whole number? Double it, multiply it by 2, okay? So what we're gonna do is anytime you get a half, so for example, if you got 3.5, if you double it, what do you get? 7. If you had 2.5 and you double it, what do you get? 5. 1.5 and you double it, you get 3. So in this case here, what we're gonna do is we're gonna multiply it by 2, but if you multiply it by 2, you have to multiply both of them by 2. So what do we get when we multiply both of them by 2? Fe2S3. And that would be your formula, or your formula, okay? So again, it's by moles, it's not by mass. This is done by moles, so you have to make sure that you're in moles. All right, last thing is calculating molecular formulas. So again, the molecular formula is the non-reduced ratio between elements in a compound. So the other one was the reduced form. Now we've got the non-reduced form. This can easily be found when you're given the empirical formula by using the following. I call it the me equation. Okay, I'll call it the me equation. M over E equation, the me. Everybody say the me equation. Me. Okay, so when you're doing the molecular formula, it starts with an M and it has an E. It's kind of easy. It's molecular over empirical. So here's how you do this. You're going to get the, leave a tiny, tiny bit of space right here. We're going to start right in the middle, okay? So you'll see we're going to end up writing something over there. So you're going to take the molecular's molar mass. You are going to divide it by the empirical formula's molar mass. This molecular one is going to be a mass that is given to you. It's given in the problem. Okay, it has to be given in the problem. So they're going to give you the mass. It'll be like usually in grams. This one here, the empirical formula, they'll either give you the formula for it, or you'll have to find the empirical formula, and you need to L-chart it. You're going to L-chart to find your molar mass of your empirical formula. Once you get this, you're going to get what I call the multiplier. And what you're going to do with the multiplier is you're just going to multiply everything by that number. For example, if you have something like C2H5, okay? So let's say there was C2H5, and you ended up getting times 3 as your multiplier, then what would your formula be? C6H15, okay? So that would be an example of if you had whatever you get as your multiplier, that's what you're actually multiplying your empirical formula by, all right? So let's just answer these questions real quick about the molecular, which are pretty easy to answer here. We already started talking about this too. So we've got, this is a non-reduced form of an empirical formula. What is the empirical formula for dinitrogen tetrahydride? What would that be? Dinitrogen tetrahydride. N2H4. Awesome. N2H4. So the question is, so that's the formula for it. So what's the empirical formula? NH2. You can divide both of them by 2, and you can reduce it and get NH2. Okay. What is the empirical formula for hydrogen peroxide? Does anyone know what hydrogen peroxide's formula is? It's like water, but there's an extra hydrogen. An extra oxygen. H2O2. Good. H2O2. So then what would the empirical formula be? H. Oh. Good. HO. It's just HO, yep. What are the possible molecular formulas for manganese 4 oxide? All right, manganese 4 oxide would be Mn with a +4 and O with a -2. So if I write the formula for it, it would actually be MnO2. That would be the actual formula. Now it is a formula unit. It's an ionic compound, bless you. So you usually would not be doing this for an ionic compound, but sometimes they'll ask you what the molecular formula versus the empirical formula are still. So technically, it's a formula unit. If I wanted a molecular formula, I could multiply by any number and it will still reduce back to this empirical. So for example, if we multiplied it by 2, what would we get? Mn2O4. What if we multiplied it by 3? What would we get? Mn3O6. What if you multiplied it by 10? What would you get? Mn10O20. What if you multiplied it by 30? What would you get? Mn30O60. If you reduced every single one of these, what would you always get when you reduce it all the way down to its the most that you can reduce it? What do you get?
MnO2.
MnO2. Okay, and that's the idea, is that the moleculars are just a multiple of the empirical. Okay. All right. So here what it says is we're trying to find the molecular formula of the compound, and we're given the empirical formula. How do we know this is the empirical formula? It's reduced. Awesome. Now that might be the molecular formula, just like I said for water. It may just happen to be that your empirical and your molecular are the same. So they also give you this molar mass. So what we're going to do is we're going to do this MEE equation. So it's N over E. This top number is going to be what you're given, and this bottom number for your empirical formula, you are going to do an L chart for your empirical formula. So what molar mass are you given in the problem? 62. Right there, it says that the molecular is 62 grams per mole. Now we need to L chart the empirical. So all we're going to do is we're going to do a little L chart here. Now, you may be at the point where you don't necessarily need to L chart completely out. You can just do it in your calculator. I don't mind, okay? So in this case, we've got 12, we've got 1, and then we've got 16. So we have a total of 31.0 grams per mole. So that L chart number goes right here for the empirical formula. So that's 31.0 grams per mole, which means our multiplier is 2. You have to get a whole number there. If you don't get a whole number, you did something wrong, okay? So this is what I'm calling the multiplier. What are you multiplying it by? The empirical formula. Good. So you're going to go back to your empirical, which is CH3O. You're going to multiply everything by 2, which means you get C, not 1 but 2, not 3 but 6, and not 1 but 2. That is called your molecular formula. Let's do another one. Let's practice one more. So paradichlorobenzene, this is the one that we used in the heating lab, the heating curve lab. So we've got M over E again, me, okay? What is the mass of your molecular? What do they give you? 147 grams for every mole. Divided by your L chart. So let's L chart this. So I've got C, H, and Cl. So I have 3 C's, 2 H's, and 1 Cl. 12 and 1, and chlorine is 35.5. Again, if you're on WebAssign, then use 1.01 for hydrogen, but we're just going to use 1 on here. So that gives me 36 and 2 and 35.5. And if I add this up, that gives me 73.5, yes?
Yep.
Grams per mole. So I've got 73.5 grams per mole. And once again, if you divide this, what do you get? 2. It doesn't always equal 2, okay? It just happened to be that these 2 examples that I did were 2. So now, when you do your molecular formula, what would it be? C6H4Cl2. So that's your molecular formula for paradichlorobenzene, okay? So the empirical would have been that. The molecular, which is the actual one, is this. Last question. This question is going to sum up empirical and moleculars together. It says you have a sample of a hydrocarbon that's going to be burned for energy. So you're about to burn some hydrocarbon. And it weighs 45 grams. If the mass percent is 79.9% carbon and 20.1% hydrogen, what are the empirical and molecular formulas? I'm going to do it the long way first, and then I'm going to shorten it, which is so much easier, okay? Let's do it the long way, and I'll show you what I mean by that. What we're first going to do is we're going to first find the empirical, and then we're going to find the molecular. Okay? The empirical formula is 3 steps. And remember, the 3 steps are, step number 1 is change your percent to what?
Grams.
To grams. Your second step is once you're in grams, you're going to change your grams to moles. Once you're in moles, you are going to write your formula. You're going to write your formula, and then you're going to divide by which one? The lowest one. Okay? So let's do these 3 steps right now. All right? So we're going to do these 3 steps. We're going to change this. Instead of percent, we're going to make it grams. So 79.9 grams of carbon and 20.1 grams of hydrogen. Step 1. Step 2 is convert it to moles. Carbon's 12 grams for every mole, and hydrogen is 1 gram for every mole. 79.9 divided by 12 gives me 6.66 moles. Again, you're not rounding yet, of carbon. And then 20.1 divided by 1, divided by 1, or 1.01. In this case, it's just going to be 20.1. Let's say it was 1.01. Then I get 19.9 moles of H. All right, so now I'm going to write my formula, which is C 6.66, H 19.9. Which one's lower? 6.66. You're going to divide both of these by 6.66, and I get C1, H what? 19.9 divided by 6.66. I get 2.987. What's that? 3. Okay, that's closest to 3. Now, if you get like 1.05, 1.09, okay, that's closest to 1. If you get something like 1.49, 1.48, that is not close to 1. What would that be? 1.5. The other thing is, if you get a 0.66 or a 0.33, if you get a 0.33 or a 0.66, that's a third or 2/3. So what do you think you would do with a 0.33 or a 0.66? Multiply by 3. Awesome. Let's come back to that for just 1 second. If the result of dividing by moles is far from an integer, you're going to multiply through by a common factor that converts all your molar amounts to integers. What I mean by that is, if you had x 1.5, y 1, okay? If you've got a 0.5, you're going to multiply both of them by 2. And if you multiply both of them by 2, then what does that give you? X 3 and y would be 2. Okay? If you had x 3 and let's make it y 2.5, what would you multiply those by? 2 again. If you multiply this by 2, what do you get? X 6, y 5. Okay? You might also get x 3, y 2.66. If you get a 2.66, multiplying it by 2 is not going to help you. You're not going to get whole numbers. What do you want to multiply it by? 3. So if you multiply this by 3, you get x 9. What would you get here? Y 8. Very good. You would get y 8. Okay? That gives you a whole number. Let's do one more. X 1.33, y 2. What would you multiply that one by? 3. And if you multiply 1.33 by 3, you get 4. Y 2 times 3 is 6. Okay? So that's how you're doing that when you do, if you get one that's, you can't round, okay? So if it's not like 1.49 or 1.51, that would be 1.5. But if you get something like 1.99, that's a 2. Or 2.01, that's a 2. All right, so just to make sure that you know how to do that. All right, so back to the bottom here. We got our empirical formula. How do I know this is the empirical? It's reduced. So now we need the molecular. So the second part of this is M over E. The molecular is given to you. Do you see it? Yes, I heard it. What is it? 45. They tell you it weighs 45 grams. That's what's given to you. That's your M. It's 45 grams. How do you find your E? You need to use an L chart. So we're going to L chart our empirical. So that E is for empirical. And if I L chart this, I have C1H3. So carbon's 12 and hydrogen is 1.0. So that gives me a total of 15 grams per mole. So I'm going to divide this by 15, and what's my multiplier? 3. Again, you should get a whole number when you do this. If you don't get a whole number when you do your multiplier, your me equation, then you probably did something wrong, okay? So then all I'm going to do is multiply this by 3. What do you get when you multiply it by 3? C3H9. Okay, bless you. That is the long way of solving the problem. Now I'm going to show you the short way of solving the problem. But you need to understand percents. And whenever you're multiplying or using percents in a calculation, everybody, what do you have to do? Shift your decimal 2 loops back, multiplied by the mass. If you do this, you're going to get how much is being represented by it, just like we were talking about the other day with the sweater. So if you know that a sweater costs $80 and you're paying 60%, you would do 8 times 6, or you're paying $48, okay? So same thing. So what we're going to do is we're going to shift our decimal 2 loops back in our percent. So instead of 79.9, we're going to get 0.799. And instead of 20.1, we're going to get 0.201. Okay? We shifted our decimal 2 loops back. That was a percent. It's no longer a percent. Okay? We're going to multiply by the mass. What mass? Yeah, the total, which is 45. You're going to multiply by the total mass, which is 45. So we're going to multiply this by our 45 grams. Does percent have a unit? Is that like a unit? No. So in this case, when you multiply these together, what will your unit be? Grams. So in this case, it's really no units by grams. So we're going to get grams. So 0.799 times 45 gives me 35.955. So I'm going to write 35.96. If we wrote 36.0, that's good too. As many sig figs as you go out is actually fine. I'll make this 36.0 just to correct the sig figs. 36.0. And that's grams. Okay, and then when we multiply these together, we get 9.05 grams. So now we're going to convert. Because we're in grams, we don't want grams. We want mils. So since we want a formula, so I'm just going to go grams to moles again, just like we did before. And same thing with the hydrogen, 1 gram for every mole. And when I do this, 36 divided by 12, it gives me 3. And if I do 9.05 divided by 1, I get 9.05, which is basically 9. Guess what your formula is here? C3H9. Is that molecular or empirical? How do you know? It's not reduced. How do you get the empirical formula? Divide both of them by 3 and you get CH3. I think this way is way easier than this way, okay, but you still need to understand this because you need to be able to do empirical formulas. So the 3 steps again, one last time are, change your percent to grams, grams to moles, then what? Divide by the lowest, okay? And then the equation is just molecular over empirical.